Hi, I'm Pat Kelly. Okay, in this problem, we're asked to find the nth Maclaurin polynomial for the given function, and for us, n is 4, so we're looking for the fourth Maclaurin polynomial. What I'm going to do is start with the formula, if you will, and I'm going to go down here because I need a bit of space for this problem. So this is where I'm looking to get an answer for p sub 4 of x. And when I mentioned formula, it's really more the general form of these polynomials, both Maclaurin and Taylor polynomials, and you'll want to know those, so get in the habit of, even as a first step, writing these out. So if we're looking for the fourth Maclaurin, I'd start with f of 0 plus, I'll pause right there in case you've forgotten, where I'm coming up with the 0 is whatever value of x you're centered around, and for Maclaurin you're always centered around 0. For Taylor it might be a different value in there. Continuing, I get plus f prime of 0 times x plus f double prime of 0 divided by 2 factorial times x squared plus f triple prime of 0 over 3 factorial x cubed. And then finally for us, the fourth derivative evaluated at 0 over 4 factorial x to the fourth. Very much a pattern, and that's why I suggest you write that form out each time. You'll get used to the pattern. You'll be able to start yourself off with a template for your answer, and now we just have to fill in the specifics. Okay? So the specifics for me, you can see we're going to need f of 0. I'm not going to do it yet, but that'll just mean putting a 0 in your function, right? Some more specifics, I need f prime and f double prime and triple prime in the fourth derivative. So that's why I held off on even f of 0. Let's find all those derivatives, and then for each one of them, we're just plugging in that independent variable of 0. Okay, so a little bit of work up here, which really just boils down to differentiation. Okay, so looks like a product rule, derivative of the first, which is 1, second left alone, plus first times the derivative of the second. We can do any derivative at this point. When I go on to my second derivative, okay, we can do any differentiation at this point in the course, but look for patterns. So when I go to do my second derivative, the derivative of e to the x just spits itself right back out again, and then you're differentiating the same product that you had originally. So this is going to equal that whole result from up above. Okay, and continuing to look for a pattern. Now realize you're going to get the e to the x, each one of them spitting itself right back out, and then we're back to that product, which is always going to spit out one term of e to the x. So I'm going to get 3 e to the x's plus, and then always that original product. So continuing that pattern, this will be 4e to the x plus x e to the x. I encourage you to look for those patterns, because if we're doing, oh boy, what if this were like a 6th or a 7th degree polynomial, you just have to do that many more derivatives, so the patterns will help make that smooth for you. Okay, now back to the specifics and the plugging in. For us, we do need f of 0, f prime of 0, f double prime of 0. So let's start filling those in up here. F of 0, just putting a 0 in for x, that's 0. F prime of 0, putting a 0 in, e to the 0 is 1, and that product's always going to be 0, so this is going to be a 1. Second derivative is going to be 2. Right, 2 different ones. I'm trying to point out the patterns. So the third derivative actually just equals 3, and the fourth derivative evaluated at 0 equals 4. Okay, so now we have some specific values to be plugging into our formula. So I'm going to go down here to do that. This equals f of 0 is just 0. I might not bother writing that. F prime of 0 was my 1 multiplied by x. I'll shift over. It's from here though. Plus f double prime of 0, which is 2. but divided by 2 factorial, which is actually also 2 squared, plus triple prime gives me the 3 in the numerator, 3 factorial, the 3's will cross out, I'm going to get a 1 over 2 x cubed, and I think I'm already to the end, plus the 4th derivative evaluated at 0 is 4. 4 divided by 4 factorial though, the 4's will cross out. I'd still have a 3 times 2, which would be 6, and that'd be x to the 4th. And that's what they wanted. This is my answer for the 4th Maclaurin polynomial for the given function f of x equals x times e to the x at the value of 0, which is given when it's a Maclaurin polynomial. Okay? That's our guy. All right. Thanks, and I hope that helped.